Hello everybody. Today I will be giving solutions and explanations to the CEMC Euclid 2023 from questions 1 to 3. So, for the first question, A, the average of n, 2n, 3n, 4n, and 5n is 18, and they want us to get the value of n. So, this is pretty straightforward. So, since the average of these five terms are 18, we could write 5 over n plus 2n plus 3n plus 4n plus 5n equals 18. And to calculate this, we would first simplify the equation to 5 over, and this is 3, 6, 10, and 15n, which equals to 18, and this is 3n equals to 18, and if you divide both sides by 3, you get n equals 6. So the first A part of question number 1 is pretty simple. And for B, suppose that 2x plus y equals 5 and x plus 2y equals 7, and they want us to find the average of x and y. Be careful since they're asking for the average of x and y and not x and y. So to solve this equation, you can, for the first expression, 2x plus y equals 5, we could move the 2x to the other side and make it y equals 5 minus 2x. And from the second equation, x plus 2y equals 7, we can plug this y value into the y value on the second equation. So that would be x plus 2, 5 minus 2x equals 7. And now it's just simplifying. X plus 10 minus 4x equals 7, and this is minus 3x plus 10 equals 7, 3x equals 3, and x equals 1. Since we found the value of 1, we can plug it back into this equation. So y would equal 5 minus 2 times 1, which gives us 3. And in the question, it asks for the average. So the average of 1 and 3 would be 2. And that is our final answer. For the last part, for question number 1, is telling us the average of t squared, 2t, and 3 is 9. And they are limiting that t is a negative number. So we could do it here. So since the average of these three terms is 9, we can use the formula like what we did in question number A. So t squared plus 2t plus 3 over 3, since there's 3 terms, equals 9. And we can just simplifying by multiplying both sides by 3. T squared plus 2t plus 3 equals 27. And we will move 27 to the other side and make it 2t squared plus 2t minus 24 equals 0. Now we have to factor it. So two numbers that add up to 2 and multiply to negative 24. That would be t plus 6 and t minus 4 equals 0. So here we get two values. T equals negative 6 and t equals 4. But the question asks us for when t equals 0. So, t is less than 0. So the value of t has to be negative 6. Okay, for question number 2a, the question is saying that if q which has a coordinate of 5 comma 3, is the midpoint of the line segment with the endpoint being p 1 comma p and r comma 5. What are the values of p and r? So what this is saying that is if there's a p coordinate here, which is 1 comma p, and there's another coordinate r, which is r comma 5, and the question is simply saying that q is in the middle here, which is 5 comma 3. So I just estimated the coordinates, not the actual coordinate, but to find this, since 5, which is the x coordinate, is the middle of 1 and r, it's like the average of 1 and r is 5. So 2 over 1 plus, or 1 plus r over 2 equals to 5. And 1 plus r equals 10 and r equals 9. And same thing like this, p and 5, the middle point is 3. So p plus 5 over 2 equals to 3. And p plus 5 equals to 6, and p therefore equals to 1. So the p value is 1 and r is 9. And for question B, a line with slope 3 and another line with slope -1 intersects at p3, 6. What is the distance between the x-intercepts of the two lines? Okay, so when we are handling with lines, we first need to know the basic form, the basic equation. So a line consists of y equals ax plus b, where a equals the slope and b equals the y-intercept. And they're giving two lines, slope 3 and with slope -1. So these two lines would be 3x plus let's just name it c, and y equals -x plus d, since we don't know the y-intercept of each line. So with this two line, it's intersecting at 3, 6. So what this is saying is that each of these line goes across 3, 6. So if we plug, so 3 is the x value and 6 is the y value, so we plug each of the values in the lines. So for this, plug 6 into the y and 3 into the x. So 6 equals 3 times 3 plus c, and we get c equals -3 here, and here 6 equals -3 plus d, and therefore d equals to 9. So we found the completed equation for each line. So each line is y equals 3x plus, or 3x minus 3, and y equals -x plus 9. And the question is asking us for the distance between the x-intercepts for two lines. So since what the x-intercept means is that when y equals 0, the value of x. So since y equals 0, we could just simply plug the y value to 0. So for the first equation, 0 equals 3x minus 3, and therefore x equals 1. And for the second equation, since 0 equals -x plus 9, x equals 9. And they're asking us for the distance. So the distance between 1, 0 and 9, 0 would be 8. Since this is pretty straightforward. So the final answer would be 8. And for the last part for the question 2, The question is saying for some value of t, the line with equation y equals tx plus t is perpendicular to the line with the equation y equals 2x plus 7, and asking us to determine the point of intersection of these two lines. Okay, so to solve this question, you kind of have to know the formulas, or like the fundamentals of the characteristic of two lines being perpendicular. So when two lines are perpendicular in a line, the slope of the two lines when multiplied should equal -1. So for example, if this is y equals 3x, then this line should be y equals -1 over 3x and plus something and plus something. But when it's perpendicular like this, the two lines slope should multiply and equals to -1. So here the slope of the first line is t and the second line is 2. So as I said before, t multiplied by 2 should equal -1. So therefore t equals -1 over 2. So suddenly we found the whole equation for the first line. Y equals -1 over 2x and -1 over 2. And y equals 2x plus 7. And they're asking us to find the point of intersection of these two lines. So we can simply make an equation like -1 over 2x minus 1 over 2 equals 2x plus 7. Since the fractions is kind of annoys me, so I would just multiply both sides by 2 since it doesn't change the whole equation. So -x, -1 equals 4x plus 14. And if you move over the x and the constant, 5x equals -15, and therefore x equals -3. And since we found the x value, we could plug the x into one of these two equations. It doesn't really matter, but since the second line is without fractions, it must be more easy. So y equals 2 times -3 plus 7, which would equal to 1. So the point of intersection of these two lines would be -3, 1. Okay, so the first part of question number 3 says that the positive divisors of 6 are 1, 2, 3, and 6. What is the sum of positive divisors of 64? So we first need to find the value of each positive divisors of 64. So since 64 equals to 2 times 2 times 2 times 2 times 2 times 2, see, because it's 4, 8, 16, 32, and 20, and 64. We can find the positive divisor of 64 as 1, 2, 4, 4, 8, 16, 32, and 64. And we just have to find the sum of this, so I just added up all the divisors. So this is 3, 7, 15, 31, 63, and the last one would be 127. So that would be our final answer. Pretty simple, and we'll move on to part B. So Fion wrote 4 consecutive integers on a whiteboard. Lexi came along and erased one of the integers. Fion noticed that sum of the remaining integer was 847. And the question is asking what integer did Lexi erase. So this question can be a bit complicated as you have to divide into different cases. So first of all, since it's saying 4 consecutive integers, I could represent the 4 integers as x minus 1, x plus 1, and x plus 2. And we have to divide each case on each integer on what Lexi erased. So case 1, Lexi erased x minus 1, and case 2 would be Lexi erased x. Case 3 would be Lexi erasing x plus 1, and case 4 would be Lexi erased x plus 2. So for the first case, since Lexi erased x minus 1, the remaining integers x plus 1 plus x plus 2 should equal to 847. So let's see if we actually get the x value, which is an integer. So 3x plus 3 equals 847. 3x equals 844. And unfortunately, x does not get an integer value, since 844 divided by 3 is not a whole number. So it gets something decimal something. So this case would not work, since x has to be an integer. And for case number 2, the remaining integers would be x minus 1 plus x plus 1 plus x plus 2, which should equal to 847. So if we simplify this, 3x plus 2 equals 847. 3x equals 845. And this also is not possible, since 845 is not divisible by 3. So the way I know this is, when the rule for if something is divisible by 3 is if the sum of each digit should be divisible by 3. So for example, 8 plus 4 plus 5 is 17, and 17 is not divisible by 3. So I already know that this whole 845 is not divisible by 3. So this case also doesn't work. So we have to move on to case number 3. If Lexi erases x plus 1, then the remaining integer, x minus 1 plus x plus 2 should equal to 847. 3x plus 1 equals 847, and 3x equals 846. And from this, I already know that 846 is divisible by 3, because 8 plus 4 plus 6 is equal to 18. So you could plug into a calculator if you like, but this equals to 282. So this case works, and I already know that this will be the only case that works, but to make sure, I will try case number 4. So if Lexi erases x plus 2, then the remaining integer would be x minus 1 plus x plus 1, 847. And if we simplify this, 3x equals 847. We know that this is not possible either, since 847 is not divisible by 3. And the question is, what integer did Lexi erase and not the value of x? So in case number 3, Lexi erased x plus 1. So the final answer should be 283 and not 282. So moving on to the final part for question number 3. The question is saying an arithmetic sequence with 7 terms has first term d squared and common difference d. The sum of 7 terms in the sequence is 756. Determine all possible values of d. So here you can solve the question if you know the formulas, but you don't have to know the formulas. You could just add each term one by one, but that would take some time. So I recommend memorizing the arithmetic and geometric series formulas. But to start off, the first term is d squared, and since the common difference is d, the terms would be d squared plus d squared plus 2d, d squared plus 3d, and so on to d squared plus 6d, since there are 7 terms. And they're telling us that the sum of these 7 terms is 756. So if you guys memorize the formula, the sum of arithmetic series is 2 over n 2a n minus 1 d, where n is the number of terms, a equals first term, and d equals to common difference. So if we just plug in the formulas here, it should be pretty simple. Sn equals 2 over 7 terms and 2d squared, since the first term is d squared, and then up to this n, and 7 minus 1 and d, like this. Since this equals 7 d squared, this is d. So I just plugged in, and this is supposed to equal to 756. So now it's just all simplifying and calculating. So if we simplify the numerator first, it would be 7 2d squared and times, or I forgot the plus sign here, plus 6d over 2 equals to 756. And to simplify even more, two over 14d squared plus 42d equals to 756. 7d squared plus 21d equals 756. And since this is a pretty big number, I looked at it and realized that all the coefficients could be divided into 7. So if I divide both sides by 7, d squared plus 3d equals 108. And if we move 108 to the other side, d squared plus 3d minus 108 equals 0. And a number that adds up to 3 and multiplies to negative 108, if you think about it, would be 9 and plus 12 and minus 9. So d plus 12 d minus 9 equals 0. So the question above asks for all possible values of d. So the final answer should be d equals to negative 12 or d equals 9. And that would be our final answer.